Kapil sir, please begin.
Yeah, good morning to all of you, all the respected research scholars, and all my dear students of Patil University. Today we have a guest with us, Mr. Atul Bajpai. He has a vast experience of almost 8 to 10 years in the industry, and right now he is working on technology of DevOps, of the Cloud DevOps, and he has gone through all the technical phases of life transition of all the companies, and all these things would be shared with him very soon. So, the agenda of the today's presentation is Cloud DevOps, and we can brief you about the presentations. So,
Hey, hello all. Welcome and a very good morning to all of you for joining this session. As my dear friend introduced me, so I'm Atul Bajpai. I am a development team lead working at Accenture currently. I have around 8 years of experience working in technology industry. I work from multiple domains, starting from banking and health, insurance to healthcare to retail and chemical industries, providing business-driven solutions to the clients. So the topic of today is cloud DevOps and how it's transforming the digital world today, and how, as a business, are impacted by this change, and what benefits and what good things it brings to the table. So that is what we are going to discuss today, learn today, and see right now as a student how it's going to help you as to build your career and make something out of it. So I'll just begin. Let me share my screen. I'll share the PPT. I hope my screen is visible to all of you. Kapil, just let me know if it's not visible. Can you confirm?
yeah, it is visible. It is
Okay.
visible and audible.
Okay, thanks for the confirmation. Yeah, as you can see in this picture, so DevOps and cloud are two different words, or I can say they are two different technologies that, when combined together, brings a digital transformation. So today we are going to learn both about separately, and then we are going to combine and see what value it can bring to the table and how it's driving the business today. Okay, let's get down with it. So before we begin, there is some agenda that I have. Since it's a time-bound session, I will be fairly strict with the time. You can ask questions in between. I'll be getting that. But there is a Q&A at the end of the session. I'll be happy to help with all your queries down there. You can also post questions to me via Kapil or through PU, Power University webinar. So that's what. Okay, so first thing that we're going to discuss today is what is DevOps. Uh, what is DevOps? Basically, we're going to understand in a general sense, then we'll try to connect with the technology and business. Why do I need DevOps? Yeah. Whatever we do, there should be a need. There is a problem, and then comes the solution. So why we're going to discuss that. And how is DevOps different from traditional IT? When I say traditional IT, it means what we used to do maybe 5-10 years back down the line to drive business, and how it's driving today with the rapidly changing work environment and the software development lifecycle. Then we have come down to DevOps process and technologies, what technologies are used to implement DevOps and what processes are followed in the implementation of the technologies. Because I believe uh, even the best of the technologies could not work until there is a clear, crystal clear process defined to get it working. Like they say, ideas don't work unless you work the idea. Okay, after this, we are going to come to the cloud computing, which is the second uh, part of the discussion. Then what are the flavors of cloud computing? Then we are going to mix DevOps and cloud to bring a digital transformation, which is already happening in the industry. We are just going to discuss it. Then I have a small business case study, which I will let you know how this technology actually get implemented and work in a business environment and what it brings to the customer. as an end user. And finally, as a student, we are, I've always been, when I was a student, so whatever I'm learning, what is the need for it and where I'm going to use it uh, when I actually start working. So why for me is very important. Whatever you learn, I would suggest to ask always why it's for me, because there might be 100 good things, but we should work towards our alignment and our aspirations. And finally, there's a Q&A, like I said. So this was the agenda for today. Okay, let's get down with it. So first things is, what is DevOps? Let's try to understand in a non-technical way, and then we'll try to combine it into technicalities and complexities. So as you can see in the slide, what is DevOps? DevOps is just a combination or a union of people, process, and product to enable continuous delivery of value to the end user. Which means with the use of DevOps, what we bring is we bring people, process, and product, the end thing that we are building together in a chain of events. And then we actually deliver it to client through a continuous process. When I say continuous, it means it's kind of a life cycle. It's never ending. You develop something, client gives you a requirement, you develop something, then you do a whole bunch of things from build to test, release, deploy, operate, and monitor, and then you push it to the live environment, like it's happening today. So that is very important to understand here. That it's not just a technical thing, it was actually brought from a business problem which needed a solution at that time. So that's why a continuous delivery of cycles is very important when in today's world, and DevOps is a solution for that. So in both the diagrams, you can see starting from plan. So first thing is we plan. If we have to build a product, we plan how to build it, what will be my objectives, what will be my strategies, and where do I think can I launch the product. So planning is very important before you actually begin anything. Once you have the plan ready, then we can move further and we can actually develop. And so that is written as code. So code is actually developing the solution. So suppose if you have to build a website, what will you do? You will write the code for that in any language, irrespective of the language we are here. So it will be Python, Java, C++, anything. You develop your code, then code is ready, but it's still not processed. It's a raw code. It has been tested as a unit testing, but it needs to be built and compiled. So when I say build, you package it together because there are when you run something in an IT world, there are dependencies around it. So if your website has to run, it has to have multiple SDKs that you must have built along with your code repository, along with your database that might be running inline. So what we have to do is we have to package it all together, which in a technical term we call as an artifact. So artifact is nothing but a package of whatever you have built with all its dependencies. Because in DevOps we do not separately deploy each of the component. That is also a way, but it's not a good practice. Once we have the code ready with and we have built using the tools, then we test because testing is very important when you send something to live environment. So we test it. There are multiple testing ways, manual, automated, a bunch of others. It goes through that process and then it's released. Released means then it's pushed from development environment to the QA environment or the production, whatever the process is, depending upon client to client. And it's totally situational how the plan was worked and how it's going to be deployed. And then finally comes to deployment. So when I say deployment, it means it's been pushed to a live environment. It's like any game or any website, you see something launched today, which means it's been deployed and it's available to end user for consume. When it's deployed, the application is running, then it's very important to operate because once the product is built, that's one time thing, not one time thing, it's basically iterative, happening every day, every week, or could be anything periodically. But to maintain the application is very important so that application runs in any situation under any attacks, basically cyber attacks, and it should be healthy and it should be always available to the customer. That's what we call high availability. So that's very important. Uh, so there's checks and processes which are handled by tools today, automated tools to get it operated, and some person might be behind that to just monitor it. And then it's very important to create logs and reports of how your application is performing in the real world or in the live environment. So we always apply monitoring to that so that we can always monitor. And that's a very good practice to do when it comes to DevOps. So that was one life cycle of DevOps that is being implemented in today's world to drive business solutions. And it's a continuous delivery process. It, you push something, it goes through the same process and deployed and monitored. So if you see it's a life cycle, it's a chain of events happening periodically. And then, okay, this is something we have to understand. So what is the need of DevOps? Why DevOps actually came into the picture? So before actually going to the slide, I would like to tell you small a story of how DevOps actually brought into practice. So when Amazon was building its cloud division, that is today we known as AWS, uh, they were firstly following the traditional approach, which was the waterfall approach. So what happened is their development cycle was getting delayed, and they wanted to bring the product very quickly to the market. As you know, their competitors were working around it, Google, Microsoft, and bunch of others, Oracle, Salesforce, and whatnot. So what they had done is they brought DevOps into the picture. So why they thought is because traditional process has its own way of working, which takes time. Because when you're following a process, you have to go by the process, abide by the process, and it's a lengthy process to deliver something. So Amazon thought, okay, why not implement DevOps and see how it works for us? And if we can actually implement in POC, we might be implementing a live environment, and our product would be accelerated to the market in a very faster time, which actually happened, and they actually delivered it through the use of DevOps. So DevOps is actually automating your manual processes. And with the use of Agile through DevOps, we actually break a big bunch of requirement into smaller requirements, and then we move on with uh, building those requests or requirements, and then just keep on adding it or assembling it together. So this is how DevOps was actually born in implementation world. So as you can see, DevOps unites the mindset of development and operations. So development and operations, like we discussed in the lifestyle, are two uh, ends of a development lifecycle. First, you develop development in the and you push it to the live environment. Then you have to get it operational. It should be running high availability. That's very important. So that is operations, where operations comes into picture. Before DevOps, there used to be separate teams, big teams for development and operations. Now DevOps has taken care of that with the use of tools. So one thing, do not think here that people are losing job. It's not that. People are changing their skill to align with the new technology. So yeah, today's business wants to release on demand with DevOps both function continuously collaborate to align with business demands within the software development lifecycle. So like this diagram, so you have a business. It could be anything. You have might have a bank, you have a small uh, scaling industries, or even a grocery shop wants to implement like Walmart. It's not a grocery shop, but anyways, yeah. So we request features. So client request features. They want to suppose as a new button in their website, and they want to operate something from that. Maybe open another page from that. So that's treated as a feature. Anything you add something as a new in your website or in your application, that is treated as a separate feature. So the whole idea was to build a website, but there are separate features inside it that needs to be built separately and pushed to live environment, and this will keep on happening, and the application will keep on building. one upon the other, on top of it basically. So in here you can see development changes feature. The DevOps culture emphasizes a common goal over the whole value delivery chain. So when I say whole value delivery chain, which means delivering the end product to the customer, your application to the customer. So that is what DevOps focuses on. All members are all members understand change and are responsible, accountable as a whole, and trust each other to deliver. So it's a team effort. So everyone has to be aligned with the request requirements and then deliver it together as a team. The DevOps technology embraces CI/CD to automate the broken delivery funnels. So here comes the CI/CD. So CI/CD is continuous integration, continuous deployment, which means you build a, what we do is build a chain of events through tools. So CI is basically continuous building your solution. You develop something, then you have to package it, test it, and get it ready for release. So there, those comes under CI. And under CD, what we do actually deploy the product to the end user or in the live environment. So that entire system is known as CI/CD. So yeah, so once development done, we come to the operation side of it. Uh, so you see two brains working together to make an application work. Then end-to-end management and traceability of software delivering during development and issue resolving. So yeah, there might be issues like you must be seeing in any of the big sites that okay, the link is not working or something is broken between or the data is incorrect. So that those are the issues that arises when an application is actually pushed due to many of the unknown issues or maybe known issues which needs to be fixed. So operations take care of that again through an automated process mostly, but there are some critical scenarios which actually require manual intervention. But that's a totally different topic. We are not getting into it. Then comes the IT governance. So when I say IT governance, as we know, governance is a general word which means to monitor. So example, security. So security is a very big concern in today's world. So cyber security is a growing field, and even DevOps has its own unit known as DevSecOps, which means to enable security as part of DevOps pipelines. So doing the vulnerability check, protecting your application against DDoS attacks and phishing attacks, malwares, all those should be done because your application has to be high availability. That is one of the key criteria uh, for this whole software development lifecycle. Then integrate software testing. So, like we said, our code has to be good, not just in working, but should be following a best practices of coding also. And that for that, integrate testing is very important. So your code is pressed through the pipeline only. You will do testing in between, not in between, but as a regular process through the various testing measures that we have available today in this industry. Okay, moving on. I think this would have been clear. Let me know if not. We can discuss more on this. Yeah. Then why? Once we understand why, we need to understand: is it actually helping from what we are doing previously, or it's just a new method of doing the same thing without any actual results? So that's what we answer here. Why is traditional IT a previous version of the DevOps, or you can say a version with limited features? And that's why DevOps came into the picture to solve those problems which were existing in the traditional IT space. So as you can see, as you are all BTech student with computer science, I guess, so you must be aware of the waterfall model. So when we talk of waterfall model, it's a software development lifecycle model, SDLC. So when we have to implement something as a waterfall model, then we have a whole bunch of process. As you can see, first we gather the requirement, then we do the design, then we do the implementation, we do the verification, then we do the maintenance. So you can see it's a sequential process. So one has to happen another. So there is a dependency. Suppose if I have to implement my solution, then I have to make sure that the design is ready, approved with the client, and it's all set to go. So unless that happens, you cannot move further. That's one of the key difference between DevOps and the traditional IT. So DevOps is a parallel process. You can do things parallelly. You can build your features parallelly, create on the design of the another feature. So everything is separated out into, or you can say broken down into multiple features instead of a whole uh, application in one go. So if we do waterfall model, we might end up taking a whole year to build a small application. And if we use DevOps, we might only take 6 months to build that application and deploy to the client. So that is what DevOps bring in. It reduces your cost, it reduces your delivery time, and acceleration to market is very fast if implemented properly. So here we can see 5 parameters over which traditional software delivery is there compared with the continuous software delivery, which is actually the DevOps. So as you can see, time to delivery. So traditional or waterfall model, there is deployments every 3 to 6 months. The requirements come, there was design, implementation, verification, and maintenance. It took 6 months to develop a solution and actually give it to the client. But through the DevOps, we can do deployments every week, which means client gave me a requirement to add a new button in my application. Okay, I got the requirement. I started working on it. I took 2 days for development. Then I pushed the code, and through the DevOps pipeline, it just got implemented in maybe 2 3 hours. So you actually broke down the feature timing. So that's what it's trying to say here. It occurs multiple times a week, depending upon requirements and what is the need of the hour. Okay, then comes quality and testing, a very important part, as not just in IT, but in every sectors of the world, quality is testing, manufacturing sector basically. Quality and testing is one of the key part. So there are two ways to do testing. One is the manual testing, where testers write a bunch of use cases and test this against the application functionally and logically. And there comes the automated testing. In automated testing also, we need to write the test cases. It's just that you do not have to validate against application. There are tools for that to do that. You just have to configure the tool and run against your application, and it will give you everything what you need as part of your testing results. And then comes the software deployment. Manual software takes 30 to 50 steps. Even DevOps process takes 30 to 50 steps, but it's just that it is automated in a pipeline in a chain of events which are handled by automated tools, and you just have to click one button and all those 50 steps will be taken care. So that's how you see, right? You do not need 30 50 people to actually monitor when the deployment happens. You would need one click to do, and it will take care of everything, but you need people to develop those solutions. Then monitoring and support. So reactive softwares and monitoring is happening regularly, and downtime is hours or days in case of traditional IT. But in case of DevOps, it could be cut down to seconds. And that is what the real value is, because time is money. Uh, Manual infrastructure setup takes 3 to 4 weeks and highly error prone. As we know, when humans do work, we are prone to error. We are not perfect. We do some, maybe even a comma is missing, it will break down the system. So it's an error prone process. And automated process is very, I won't say error prone, but it's very preventive to being errors because it's happening through tools which are configured, if configured properly, should work fine. So that is how traditional IT was, this DevOps happens. And I think I've listed out some key features. There are a lot to discuss on this. Yeah. Then this is a big picture to understand. Okay, so DevOps process and technologies. So basically, when we say DevOps process and technology, I've not talked about here about agile. So that is all. That is a process through which DevOps is actually implemented. But when we have entered into actually the build life cycle, then we just have to focus on these key parts. and those are plan, build, continuous integration, deploy, operate, and continuous feedback. So this is the development life cycle of the DevOps. And as you can see, like I've talked so much about automation in the DevOps, and everything is happening through the tools. So in this diagram, you can see there are so many tools available for each of the step in this. So if you have to plan your application, how to build it, you see there are a bunch of applications, some open source, some enterprise, but everything is available in the market. And the best thing about DevOps is that orchestration. You can orchestrate your entire life cycle with the use of different technologies, starting from the language to the databases. So nothing is constrained here. You just have to pick the right tool for your requirement. So under plan also, there are a bunch of tools like Office You're Aware, Cliffy, Dropbox, Basecamp. So once you are done with planning Microsoft Teams, once you're done with planning, then you have to actually build your code. And for that, one of the best tools in the market that is available is GitHub, which is an open source tool. And this has a very huge community. You can find many of the source code repositories here. And the second one is, I would say, Docker. So today's world is everything we are containerizing, means packing it together and then delivering to the client. So Docker and Kubernetes is another two great tools that are rapidly growing in the industry these days. And then continuous integration. Continuous integration, that means you have to build your code, test your code, and make it ready for release. So to do that, we have so many tools. Uh, Zoho is an enterprise suite provided by Zoho company. ServiceNow we have, Cucumber we have. For testing we have Selenium, Finesse we have. Sales, okay. These are the tools that we can use. Then we have to operate our system. So sorry, we have to come here. We have to deploy our system. After integration is done, then we actually push it to deployment. So for deployment also, there are so many tools like Google Cloud Platform, Microsoft Azure, Amazon Web Services, HashiCorp, Rackspace. These are all big giants in this space. And yeah, for integration, these were the tools I actually ran wrong. So TeamCity, Jenkins, all good tools, fairly easy to implement once you have gained the right skills. And for coming to the language also, there is no barrier. You can use any language starting with Python, TypeScript, JavaScript, or whatever language you're working on these days, Ruby. So it's what I want to say is that it's so good that orchestrate anything depending upon your requirement, and there are tools available to handle everything in this process. And then we have once we have deployed our application, it's live, it's working on a live environment. Then we have to make sure it works fine. It keeps on operating the way we want, the way we have actually planned. And to do that, we have again so many tools. Nagios is one, Slack is one, Dynatrace is one, Datadog. So there are a whole bunch of tools that you can select from to handle each step in the DevOps lifecycle. Although I won't say that one who works in DevOps knows all the tools, but what is important is, yeah, at least you should know one good tool in each step to get your product implemented in a good way. So, okay, let's move forward. Yes. And we have talked about DevOps. Now we come to the cloud computing side of it. So cloud computing is another different process. And sorry, I have to move my. Yeah, cloud computing is another process. So cloud computing papers were given about this uh, phenomena, or you can say this concept in 1990s, and but it actually came into existing starting from 2000. Development started around 2004-5 and it actually came into the market um, during the start of the 2011s or 2012s. So what is it? So basically, there was a on-premise system and there are cloud computing. So when I say, okay, before we actually dive into technicalities, let's try to understand in a more general world. So suppose if you have to travel from Mumbai to Pune, there are multiple options to do that. First option is that you buy a vehicle for yourself, car or bike. You buy the petrol, you fill it, and then you move from one city to another. So what that would do is, for that to happen, you have to buy a vehicle. You have to incur a capital expenditure, upfront cost you have to pay. You have to buy vehicle, petrol, you have to give toll tax and multiple bunch of things. So you have to spend a capital expenditure on it. But there are other ways to do that. I can get a cab. I can just pay the cab driver the amount that is asking, and I can just move from one city to another without any hassle. So what happened in the two approaches? Suppose if you have to buy a car, you might have to spend 5-10 lakhs on it, and then I might actually travel from Mumbai to Pune. But if you take a cab, you don't have to do anything. You just book an Ola cab. You directly move from one point to another. Just paid for whatever amount you travel, maybe 500 or 1,000 rupees. So you see, there is a huge gap of money here. That is what cloud computing is solving these days. So when we come to IT space, so client has their dedicated environments. So if an application has to run, there has to be a good infrastructure around it. There has to be virtual machines, there has to be virtual desktops, there has to be databases, software platforms. All those has to be buyed upfront, which is a very costly affair, and it has to be managed by the business, which means the client. But if we talk about cloud computing, that is not the case. So again, comparing Ola with the actual car that you buy. So in cloud computing, there are vendors who take care of all the underlying infrastructure, all the underlying dependency. What as a client we should have to do is just give them our code, push the code to the repository, and then it will take care of the whole infrastructure underlying. It will give you servers, virtual desktop, data platforms, and a whole bunch of services which are required for application to run. And that will for that we just have to pay the amount for whatever we use. Suppose we want to use the data platform for maybe 1 or 2 days. So I just have to pay for 1 or 2 days. I do not have to buy the whole storage system. So if I was paying 1 million to actually even use 1 or 2 days, now I just have to pay in dollars. That is a huge gap. So that is what cloud computing brings to table. The underlying infrastructure is taken care by some other vendor, and as a end user, we just have to access it via any device, like it's shown as mobile, laptop, printers, and desktops via internet. So that is what cloud computing brings in. So as you can see, cloud models are three types actually: infrastructure as a service, platform as a service, software as a service. And then there's another picture which is capex versus opex. So we'll discuss about this before we do into cloud models. So capex is again capital expenditure, and opex is operational expenditure. So capex is whatever you pay upfront to avail the service, and then you keep on using it, maintain it via your own money. And OPEX is I just pay for the operation that I just did, nothing else. I do not have to worry about the infrastructure. I do not have to worry about the maintenance. I do not have to worry about any of the stuff that is used to run my application. I just have to pay to run my application for that time being or whatever time, periodic time I'm going to use it for. So it's going to save me a lot of money. It's something you can say, think in like renting out. You don't have to buy a house. You are just taking something on rent for a certain period of time and then using it. It's just the same way in IT. So infrastructure as a service. So again, when it comes to cloud models, there are multiple set of services provided by the cloud vendors, whatever you want to use. So if I talk about on-premise system, which is buying everything upfront, that is spending the capex or the capital expenditure. Then application. data, runtime, middleware, OS, virtualization, servers, storage, networking. Means everything you have to be managed by you, which is the business or the client. But if I say I would take infrastructure as a service from some cloud vendors, then what happens is I do not have to worry about the networking. I do not have to worry about storage, servers, and virtualization. These will be managed by provider, and I will just have to pay as a rent on it. I'm not going to buy it. And rest of the things are managed by me, which is application, data, runtime, and middleware and operating system. This is the first step, infrastructure as a service. Then came platform as a service. So the cloud vendors think, okay, when we are giving this much to you, okay, why not expand it? So what they said is, okay, we'll provide you a part along with virtualization. We'll also provide the operating system, middleware, and we'll take care of the runtime. You just have to worry about the data, which is yours, an application which is going to be run. So this is what platform as service provide to you. It's give you everything, and you just have to deploy the application and run it. Then give software as a service. So here, it is totally managed by provider, and everything is taken care by the provider, and you just have to rent it and pay it. And one very good example of this is uh, Microsoft Office. So everything is handled by Microsoft. You just use Office, so and you just pay yearly, whatever the cost is. You don't have to worry about anything. You just go there, use Excel, PPT, and everything in Office. So there are many, even Outlook or Gmail. Those are all software as a service. Yeah. So just to make it more clear, I would try to visualize this in the real world. So I take an example of new pizza as a service. So if I have to buy a pizza, there are two ways. One was the old approach, and one is the new approach. In the old approach, you have to make everything in your house. Kitchen has to be yours, gas has to be used, oven, pizza dough, topping, cook the pizza. Everything is in your hand. Everything work out fine, not work out, it's up to you. Nothing that someone else will do. But if you take infrastructure as a service, you just have to worry about pizza dough, topping, and cook the pizza. Kitchen will be provided by someone else. If you use platform as a service, even pizza dough will be provided by someone else. You just have to cook it. They will give all everything you need to cook a pizza, and they will just give it. Then comes the Domino's. You just go there, you avail pizza as a service. You pay for the pizza, you buy it, you eat it, that's it, you're done. So you can think Domino's as software as a service as an analogy. Okay, we'll move further. Okay, so we'll see who are the top cloud providers to these days. So running on the front lines are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. These are the three top cloud providers which owns about 85% of the market today. So they are very heavy players, but there are many other players in the market from IBM to Oracle Cloud, Salesforce, DigitalOcean. So everyone contributes, but these are the ones who actually brought cloud into an implementation, and they are taking the race forward. So as we all know, these are all very big companies. Okay, so DevOps plus cloud. So this is something very hard to come, and we discussed so much about cloud and DevOps. So actually, okay, where it will take me, if we mix those two technologies, what can I get? So the thing is, it could bring when we do the case study, we'll see the benefits of it, what it actually brings, because uh, in any world, the success measures are taken in certain ways. How much money I'm saving, how much time I'm saving, and how good my product is to the end user. So if you check all these three factors, your business will always be in profit. And that's what we aim to provide our customer, to make their revenues grow through the use of technology. So DevOps and cloud being these digital change. So there was an old way which was taking around 1 year to develop a solution. Then we brought DevOps. We do code, build, test, release, and operate in a single chain of events. And that too, we are not expending capital expenditure on it. We are using cloud providers to host our application, run our application, operate our application, and provide the maintenance windows and everything. I just have to worry about my code. That's it. And which was already taken care in a good way through my DevOps pipeline chain. So that is where the underlying keys are. We come to a new way. So like in any word, evolution happens. This is the evolution of IT in this decade, I would say. So it started in 10 to 20, and now it is on a booming phase. Everyone is just trying to implement cloud and DevOps in their business uh, to come to new way and make the best use of the technology that is available in the market today. So I would not say traditional was not a good approach. It was a good approach at its time because that's how we have evolutionized. Everything we do is a stepping stone to the next step in our journey. So this is what the next step is in for this decade and coming decades. Cloud DevOps would be implemented everywhere. So that's how we come to a new way and we do a digital transformation. That's why I'm saying it's a transformation happening, which is very important to drive the business today. Okay, so we have learned so much about cloud and DevOps, and but what it actually brings to the table for me, why should I do it? As a student, everyone should be curious. Okay, if I'm learning something, how I'm going to use it and make something out of it for me, which is useful to build a career for me. So that is the key question we should be taking away from this session because learning DevOps takes time and it will bring something good for you. So I would try to depict it through data because that I believe is the best way. So these are all source data. So first is global DevOps market by application 2018 to 2028. So it's showing where it was in 2018 and how much growth it will take when 2028 comes. So this should, I see it's a linear growing graph, which is a very good graph. And if you see, it's in terms of US million dollars and it's 1790 that's going to happen. Now, that is number of applications. And if we see every sector you pick is taking the use of cloud and DevOps these days, starting from banks, retail, IT and telecom, government, healthcare, manufacturing, media. So as we know, everything is digital today. We stick to our mobiles and laptop screens for nearly half of our day. And we see the world is changing very rapidly. For instance, you get your product or in a mobile, you get updates every month. So that is all happening through the use of DevOps because acceleration to market has been faster. But maybe in 2010 or 20, starting of 2000, it was not so fast. We were not getting mobile updates until a year, maybe. But now that is not the case. And DevOps has solved all those. So that's why, and it was started in certain sectors previously, but now every sector is getting seeing the use of it and how they can benefit from it. So if you can see, everyone is taking use of uh, the DevOps. And when it comes to demand, because as we know, everything is a game of demand and supply. So there is a demand to implement DevOps. So there will be demands for people to implement DevOps. So these are top tech roles ranked by employer demand. So if you see, DevOps is the third best option. But when you bring DevOps and cloud together, it might get to first best option. So there is a huge need of people in DevOps these days. Um, for instance, I was hiring people for my project, and it was very hard for me to find good engineers who could actually work and implement DevOps. So every big companies in every sector is looking for engineers in cloud and DevOps. So that's a very good future option for you if you go pursue it. So that's why it was necessary to discuss, because what are we getting from it? And they are good paying jobs, which like and help you build a good future in the technology industry if you're going to pursue it. So this was why you should do cloud DevOps. Why I would recommend you to do cloud DevOps along with many other technologies that are available in the market today. So yeah, this was why you should do the cloud DevOps. Now I have a business case study. It's a small case study we are going to do to understand how business is impacted today. Okay, so it's a small case study only. I'm not going to read thoroughly on it, but I'm going to give you the key insights into this. So this was this technology company, PSL, who's implemented cloud DevOps and what they have achieved from it. So what it's trying to say is cutting deployment time by 50% faster and infrastructure cost by 30% with DevOps. So which means if application deployment was taking 6 months, 3 years back, with the use of DevOps, they have brought down the application deployment time from 6 months to 3 months. That is halving half of the time. And infrastructure cost is reduced by 30%. So if someone was spending 100 rupees on infrastructure to run their application, with the use of Cloud DevOps, they only have to spend 70 rupees on it now. There is a 30% reduced benefit on cost, which is a huge number when the value goes bigger. When you talk, because business applications runs in millions and billions of rupee dollars, so 30% is a huge amount. So that's what they have bring for one of the customers. So what result they have gathered, fetched from their cloud implementation? So faster time to market, like we discussed, reduced 50% of the deployment time. Now the application is only getting built in 3 months. Refactored the cloud architecture. When I say refactor, which is making the best use of cloud architecture. So we have just been taken a bird's eye view on the cloud as of now, but there's a lot to explore on that. One key thing I should have told maybe is the types of cloud. There are public, private, and hybrid cloud available. So they are trying to use, or may have used the best out of it, depending upon the situation, which in this case was a hybrid cloud model. Uh, and then 30% reduction in infrastructure cost. Like I said, it's a big amount of money to, if someone say, okay, I'll take 30 rupees less, I'm sure you would buy something from that vendor. And 30-40% less time in CI/CD pipelines getting to one click deployment. Like we discussed, in the implementation of a application, there are hundreds or 50 steps to be taken care. But with the use of CI/CD pipeline, everything is happening use of a one click. And automated tools are running everything behind and the backend for you. So everything is so fast and so easy once the solution is built. And for this client, they were actually overseeing 15 plus applications. So 15 different applications and all productive, high availability, high scalability products. You can scale up, scale down every time, depending upon the need. You don't have to pay. That is actually using the best way of cloud, scaling up and scale down as per the requirement. Nothing extra, nothing more. And database migration of 400 million records they did. So they had 400 million records in the database, which were actually migrated from an on-premise database to a cloud database. So this is what the benefits they gain from the implementation of cloud DevOps. And that is what every client is looking for today, to accelerate their product to market in the faster way, reduce deployment time, save money, and do it in an automated way and very easy to handle. So all those problems that were there in traditional ITBS actually solved with the use of cloud DevOps. And that is why it's such a growing uh, area in the world of IT today. So this is the executive summary. So this is a geolocation company, which means it was operating in multiple places from US and Europe, wanted without DevOps, but finding it challenging to staff and scale their fast-paced project locally. Rather than outsource their DevOps adoption through a traditional vendor client outsourcing, they leveraged PSL's DevOps capability by creating hybrid teams, and they brought down the time so faster. And these, like in one of the slides, we discussed the tools available to implement your solution. All, all there were so many tools, but this client actually used these many tools to implement each of their steps. So Docker, Jenkins for their continuous integration, AWS as their cloud provider where they are going to deploy the solution, JIT where they're going to build the solution, and Jira where they're going to do the reporting, and Python for the actually code language that the application was built on. So with the use of all these applications, they have built a DevOps pipeline, and then there's just one click and everything runs sequentially, and the application is deployed in a very, very quick way. So if you read this, I would send this PPT to everyone join the session so that they can read and understand how they actually solved and what solution they provided. So we are short of time, so we are not going to delve deep in it. We are already 3 minutes just left for the session. So I'll take some time for Q&A if someone has any questions. So yeah, please feel free to ping or just let me know. I'll be happy to help. Hi, Kapil. We are open for Q&A.
Yes, sir. It was really a very fantastic session. We, the Parul University, are very grateful to you, and we will see you in the future very soon. You've shown how the trend of DevOps is going on by showing a bar graph presentation. It was really very good, and the trends are going on. So it would be very beneficial to the students who are aspiring their career in DevOps or those are thinking of doing it. So thank you very much, Satul sir. You can leave now.
I appreciate your efforts bringing me in, and I really value the appreciation.
Yeah,
Thank you. Thanks a lot.
yeah. Thank you once again.
But I'm open to questions right now. We have given 10 minutes time for Q&A if there are any. Okay, I don't see any question. I won't take any much further to drag the session. Thank you all. Thanks for joining. Have a great day. Have a great weekend, and happy building career. Bye bye.
Thank you, sir.
Yep. Thanks, Kapil. Thanks a lot.